Hello everyone, this is my channel Class 10th Maths and I am your teacher Karuna Gupta. This is uh, this chapter 17 has been taken from Class 10 Concise Mathematics Selina publications by R.K. Bansal, which is of 2024 edition, and the chapter name is circles. Okay, so we will be doing circles in this presentation. Coming to the introduction, children, 17.1, point number 17.1, introduction. What is a circle, children? A circle is defined as the figure, closed curve obtained by joining all those points which are at a constant distance from a fixed point in the same plane. Okay, it is not a 3D figure. Okay, it is a circle and it is two-dimensional, that is in the same plane. A circle is defined as a figure that is a closed curve. Okay, and it is obtained by joining all those points which are at a constant distance from a fixed point. We take a fixed point, and from that fixed point, suppose we take 5 centimeter 5 centimeter length, and we make points 5 centimeter from that point in a curve, like going around, like a circle, going in a round manner. Okay, then that will give you a circle. In fact, a circle is the locus of a point which moves in a plane in such a way that its distance from a fixed point in the plane always remains constant. Okay, locus of a point means moving a point in a at a certain distance from the fixed point. The fixed point is called the center of the circle and the constant distance is called the radius of the circle. The perimeter of the circle is called its circumference. Okay, children, the perimeter, you will be understanding all this in the coming slides. See, now see this. This is the center. Okay, this is a circle. Suppose this is the radius. Okay, this is the radius, and this radius is same for this, for here, from here, all have the same length. Okay, this is the diameter, which is the longest chord which passes from the center, that is, it is the diameter which cuts it into two halves. Okay, and this is a chord which joins two points on the circumference, and this is the circumference of the circle, children. This line, the whole line is the circumference. Okay, and this is the radius, this is the, and diameter, you can see this is also the radius and this is also the radius, so diameter is 2 times radius. Okay, 2r. Now what are concentric circles? See this, children, there is a point O and there is one circle, then second circle and third circle. Okay, two or more circles are said to be concentric when they have same center and different radii. Means the center is same but the radius of the circles are different, they are of different length. Okay, now coming to equal circles. Circles are said to be equal or congruent. Okay, when they have the same radii, like the length of the radii is same, here is one circle, here is one circle. If the radii is 5 centimeter for this and 5 centimeter for this, then both the circles are called equal circles. Okay, circumscribed circles, a circle that passes through all the vertices of a polygon is called a circumscribed circle, and the polygon is called inscribed polygon. Example. Okay, you are able to understand, a circle which passes through all the vertices of a polygon is called circumscribed circle and the polygon is called inscribed polygon. Because the circle passes through all the points on the of the polygon, so it is called circumscribed. It is outside, so it is called circumscribed. Here also, here also there are 5 points, there are 4 points, here there are 3 points, and the polygon, this polygon is called inscribed polygon. This is inscribed polygon. Okay, this is inscribed polygon. What is inscribed circle, children? A circle that touches all the sides of a polygon is called inscribed circle. Suppose you draw a polygon and the circle you draw inside it a circle, then that circle if it touches all the sides of the polygon, then it is called inscribed circle or in circle of the polygon. Okay, the center of the inscribed circle is called in center, and the polygon is called circumscribed polygon. Okay, see below. This is circumscribed polygon because it is covering all the sides. It is covering the circle. Sorry. Okay. This center is called in center. This is the inscribed circle or in circle. Okay. And this is the circumscribed polygon. Understood, children? This is in center. This is the in circle or inscribed circle, and this is the circumscribed polygon. I hope you understand. Chord. Now what is chord? The line segment joining any 2 points on the circumference of a circle is called a chord. Okay, a line segment which joins any 2 points. A chord which passes through the center of the circle is called diameter and is the largest chord of the circle. So, and it is also the largest chord of the circle. Suppose there is a straight line drawn from the center of a circle which bisects a chord. Suppose AB is a chord and O from O is the center, and a straight line is drawn on the chord which bisects the chord, means divides it into 2 equal halves. That is AM is equal to MB. Then which is not a diameter. This chord should not be passing through the center, that is it should not be the diameter, is at the right angle to the chord. So this OM is perpendicular to AB, that is OMB, angle OMB is equal to 90 degrees. In the given figure, line OM drawn from the center O to bisect the chord AB is perpendicular to AB, that is AM is equal to BM, and OM is perpendicular to AB. Therefore, angle OMA is equal to OMB is equal to 90 degree. That we have seen. Now see this point, children. The perpendicular drawn to a chord from a center of the circle bisects the chord AB, that is implies that AP is equal to AB. Okay. Suppose there is a chord AB and a perpendicular is drawn from center O to point on the chord. So when the perpendicular is drawn, then we can it implies that it divides the chord into 2 equal halves, that is AP is equal to PB. Okay, children. Now remember this point. Greater is the size of a chord, smaller is its distance from the center, and vice versa. What is the point, children? The greater is the length size of the chord. Okay. If the chord is of smaller size, suppose only this much, then it will be farther from the center. Okay. But if it is a chord is drawn like this, so it will be nearer to the center. That only this point says. Okay, that when a chord is bigger, its distance is smaller from the center, and when a chord is smaller, its distance is farther from the center. Okay, in the adjoining figure, O is the center. This is the center. OP is parallel to AB. Okay, and OQ is parallel to CD. Chord CD is greater than chord AB. That is OQ is greater than OP. Okay. OQ is less than this chord CD, this chord is greater than AP. Okay, though in the figure you are not able to we are not able to distinguish much, but we assume that chord CD is greater than chord AB. The length of the chord CD is greater than length of the chord AB. Okay, then what happens that this distance is smaller. OQ is less than OP. This length distance is smaller because this chord is bigger and this chord is smaller. Okay, then the OQ is less than OP, and O is the center, and OP and OQ are the two perpendiculars drawn from O on AB and CD respectively. Okay children, I hope you are understanding. OP and OQ are the perpendiculars. Conversely, as OQ is less than OP, or we can say that as OQ is less than OP implies that CD is greater than AB. Means OQ is the length of the is the perpendicular drawn on CD, and it is less than OP. So therefore, if OQ is less than OP, CD is greater than. CD means the chord CD is greater than AB. Okay, because it will be nearer. Okay, there is one circle and only one which passes through three given points, not in a straight line. Okay, if there are 3 points and we have to make a circle passing through those points, then there can be only one circle which passes through the given points which are not in a straight line. Okay, equal chords, this is also a conclusion. Okay, a point which you should remember. Equal chords of a circle are equidistant from each other. Suppose equal chords, the length of the chords are equal. Okay, suppose in this case AB was equal to CD, then what happens that they are equidistant from the center also, that is O. They are from O, point O, they will be if a perpendicular is drawn on them, then the perpendicular will also have equal value, that is OP is equal to OQ. Okay, chords of a circle equidistant from the center of the circle are equal. Okay, chords which are equidistant from the center of the circle, like this, equidistant from the center of the circle, that means OM and ON are equal. Okay, so if OM and ON are equal, means that AB is equal to CD. Understood children? In the given figure, if AB is equal to CD, implies that OM is equal to ON, right? And secondly, if OM is equal to ON, then AB is equal to CD. Okay children, it was easy. You can understand this easily. Now coming to what is arc and its types. 17.2 point number 17.2, that is arc and its type. An arc is a part of the circumference of a circle. A chord, okay, it is a part of the circumference of a circle, like chord which was drawn inside a circle. Okay, but chord arc is on the circumference of the circle. Okay, it is not inside the circle, it is on the circumference of the circle. A chord divides the circumference of a circle into two parts, and each part is called an arc. Okay, this chord AB is dividing this circle into two parts, that is APB, okay, and AQB. Okay, this is one arc and this is another arc. This circle is divided into two parts. Okay, the bigger arc, bigger part, and the smaller part. Okay, in like you can see in the given figure. Chord AB divides the circumference into two unequal arcs, APB and arc AQB. The arc APB, which is less than the semicircle, is called minor arc. Okay, semicircle means which the arc, if the chord passes through the center, that is called diameter. So if the chord is less, if the arc is less than semicircle, it is called a minor arc, and the arc AQB, which is greater than the semicircle, it is called major arc. Okay, children. Now, children, coming to point number 17.3, that is segment and relation between two arcs and segments. Okay. A segment is the part of a circle bounded by an arc and a chord. This part bounded by an arc, this is the arc, and this is the chord. This is called, the inside part is called the segment. Okay. What is the, we are studying the relation between arc and segment. See, this is this arc and this chord. This part is called the major segment, and this arc and this chord, this is called the minor segment, as you can see by yourself. Okay. Theorem 1, children. The angle which an arc of a circle subtends at any point on the remaining part of the circumference. The angle which an arc of a circle subtends at any point on the remaining part of the circumference. We will be studying about this. There is a circle with center O, an arc APB with subtends an angle AOB at the center, and angle ACB at the point C on the remaining circumference. Okay, let's see how. See, we have to prove that angle AOB is equal to 2 times angle ACB. First, let us see the circle. This is the circle. Okay, this is one chord AC, this is second chord BC, and suppose we join, this is the center O, we join OA and OB. OA and OB are the radius of the circle. Okay, and what we do, we join C and O, this is also the circle, radius of the circle. So all of these are equal, OA, OB and OC, all of them are equal, and we extend this O point till D. Okay, so construction, what do we do here? What we have to prove here is that angle AOB, angle that is subtended at the center, is twice the angle at the circumference. Okay, that is angle AOB is equal to 2 times angle ACB. Okay, now how we prove it? We will join CO, okay, and produce it to a point D. Okay, proof, statement and reason. In triangle, we have to prove, like when you write the proof, you have to first give the statement and also give the reason. Okay, in triangle AOC, first take the triangle AOC. OA is equal to OAC, OA is equal to AC, therefore angle AOC, sorry, AOAC is equal to angle OCA, right? Angle OCA is equal to angle OAC, because radii of the circle are, OA is equal to AC because they are radii of the circle, and OCA is equal to angle OAC because angle opposite to the equal sides of a triangle are equal. Opposite sides of the angle opposite to the equal sides of a triangle are equal. Angle, third point is angle AOD is equal to angle OAC plus angle OCA, because exterior angle of a triangle is equal to sum of interior opposite angles. Okay, is equal to OCA plus OCA, because OAC is equal to OCA, we have proved before, because we have proved before, therefore this OCA is plus OCA is equal to 2 times OCA. Similarly, in triangle BOC, exterior angle BOD is equal to 2 times OCB. Okay. You can see the diagram in the previous page and you can see the solution here. Exterior angle BOD will be equal to 2 times OCB. Okay. And what is angle AOB is equal to? Angle AOB is equal to angle AOD plus angle BOD is equal to 2 OCA plus 2 times OCB. Therefore, 2 times OCA plus 2 OCB is equal OCA plus OCB. What is OCA plus OCB? It is 2 times angle ACB. Therefore, angle subtended at the circumference is half of the angle subtended at the center by the same arc, or it is angle subtended at the center is twice the angle at the circumference. Okay, hence proved. In the given figure, see the given figure children, O is the center. This O, there is a center. Okay, O. X is equal to 2A. X, the value of X is 2A, 2 times, because yes, we have just proved it that the angle subtended at the center is equal to twice the angle at the circumference. Okay, now this Y is equal to, and secondly Y is equal to 2B, because Y is the reflex angle and reflex angle, sorry, and it is equal to 2B. Y is the angle from the bigger arc. Okay, and this is the angle which is subtended by the bigger arc on the circumference, and this is the angle which is subtended at the center. Okay, now similarly in the following figures, angle 1 first. Okay, APB and angle AOB. There are two this, see this arc AB. Okay, when this arc subtends the angle APB on the circumference, P is on the circumference and this arc takes this angle on the circumference, and when we join it with the center, then this angle, this arc subtends this angle at the center, that is angle AOB. And what we have proved, that angle at the center is twice at the circumference, therefore angle AOB is equal to 2 times angle APB. Okay, this equation will be used many times children in your answers. Okay, now coming to question number 2, angle, suppose this is the circle. Okay, and this is the angle APB is the angle subtended by this circumference, right? The bigger circumference. It is not by the smaller circumference, it is first subtended by the bigger circumference. And what is the angle subtended by the this arc on the center? It will be this one, not this side, it will be this side. Okay, because this side means for this one, this side, this arc. Okay, so this is the angle subtended at the center. Therefore, reflex angle AOB, that is 360 minus angle AOB, okay, is equal to 2 times angle APB. Understood children? I hope you are understanding this. Once more I will explain this to you. See this APB, this is the circle. Here the center is an angle is subtended at the center AOB. Okay, it is one, here it is this side, and one angle this is this side. This is the bigger arc of the circle, and this subtends an angle APB at the circumference. Angle at the circumference is half at the angle at the center or angle at the center is twice at the angle of the circumference. So reflex angle AOB, because this will be the angle. Okay, reflex angle AOB is equal to 2 times angle APB. Okay, I hope you must have understood now. 2 times angle APB. Theorem 2, children. Angles in the same segment of a circle are equal. A circle with center O. Angle ACB and angle ADB are in the same segment. How? This is the arc, okay, and they are drawn. One is drawn on the right hand side and one is drawn from here. Two chords are joining here and the same arc. Can you see the arc? AB, APB. This is the arc and this is subtending an angle ACB at the circumference and angle ADB at the circumference. Okay, we have to prove that angle ACB is equal to angle ADB. Okay, this angle is equal to this. Angle ACB is equal to prove what? Angle ACB is equal to angle ADB. Here we can join these 2 points, that is angle AOB and OA is equal to OB, because it is the radius of the circle. Understood, children? OA is equal to OB. Okay, if OA is equal to OB, what will happen? Let's see next. Construction, join OA and OB. We have joined OA and OB. Arc APB subtends angle AOB at the center and angle ACB at the point C of the remaining circumference. Because arc APB, we have seen the same arc is subtending our angle APB at the circumference and angle AOB at the center, and therefore angle AOB is equal to 2 times angle ACB. Angle at the center is twice at the remaining circumference. Okay, that is the reason. Now similarly, angle AOB is equal to 2 times angle ADB. Okay, angle AOB is also 2 times ADB. Therefore angle ACB is equal to ADB, because AOB is also 2 times ADB and 2 times ACB. Therefore ACB is equal to ADB from 1 and 2. Hence proved. Okay, understood, children? This is that angle at the circumference and between angle which are drawn in 2 segments which from the same arc are equal. Similarly, in the adjoining figure, see this figure, children. Now see, this is the arc and here DAB, this is one segment, segment, and DCB is the same. This is another segment which is formed at the circumference with the same arc. Okay, see the arc DB only with the same arc, that is DB. Okay, this is formed on the right hand side, and this, there can be any number of arcs, segments here. Now angle DAB is equal to angle DCB. We have just proved that both angles in the same segment are equal. Okay, now consider this segment, children, this top segment AC. You will see that this is one angle at the circumference and this is the second angle at the circumference, that is angle ADC is the first angle at the circumference and angle ABC, it is the second angle at circumference. Therefore angle ADB is equal to angle ABC. Okay, so you have to check like where is the arc and where it is subtending the angle at the circumference and where it is subtending the angle at the center, so that we can equate it and find the answers. Okay, now theorem 3. The angle in a semicircle is a right angle. Okay, till now we have studied small arc, like minor arc and major arc. Okay, a minor segment and major segment. See, now the chord is passing through the diameter, center. So it is the diameter, and it is dividing the circle into two halves, that is one is two semicircles, right? When what it says that the angle subtended by a semicircle is a right angle. This is the semicircle AB, okay, and this is the arc AB, which is until here AOB, and this arc with this chord is the semicircle, and this is subtending an angle ACB at the circumference. Can you see that? That joining this point to the circumference and joining B point to the circumference. Then what we get? ACB. Okay, which is the point of the semicircle. A circle with center O. This is the circle with center O. AB given, what is given? A circle with center O. AB is a diameter, and angle ACB is the angle of the semicircle. Angle is to what we have to prove? To prove that angle ACB is equal to this angle ACB is equal to 90 degree. Okay children, let us see here only. What is angle AOB? This angle hold at the center. This angle is 180 degree because it is drawn on the straight line. You all know that this is 180 degree and this side also 180 degree. So it will become 360 degree. So angle AOB is 180 degree. And what happens? But the angle which is at the circumference is half of the angle at the center. So what will be angle ACB? Angle ACB will be half of angle 180 degree, that is 90 degree. So we can prove like this, that it is half of AOB. See the proof, the statement and the reason. Arc APB subtends angle AOB at the center and ACB at point C of the remaining circumference. This you have seen how the arc has subtended the. Then angle AOB is equal to 2 angle ACB. Angle at the center is twice the angle at the remaining circle. You can see children, angle AOB is equal to 180 degree. That angle AOB is a straight line. 2 into angle ACB is equal to 180 degree. From 1 and 2, angle ACB is equal to 90 degree, hence proved. 17.4 cyclic properties. When a quadrilateral is inscribed in a circle, inscribed means inside a circle, the vertices of the quadrilateral is on the circumference of a circle. The quadrilateral is called a cyclic quadrilateral. Suppose here is a circle, okay, and suppose you draw a quadrilateral like this, okay. All the circle vertices are on the circumference of the circle. Then this is called a cyclic quadrilateral. The points which lie on the circumference, like A, suppose this is A, this is B, this is C, and this is D. Then the points which are on the circumference of the circle are called concyclic points. Okay, concyclic points. So it is not easy to draw with this. So you understand the children that A, B, C, D. So A, B, C, D are called concyclic points. Now theorem 4. What is theorem 4 children? It says that The opposite angles of a cyclic quadrilateral inscribed in a circle are supplementary. Supplementary means they both add up to 180 degree. Okay. How? We will prove it. Okay. A quadrilateral ABCD, A, B, C, D. Okay. That is like this. Is inscribed in a circle with center O. Okay. Angle ABC, what do you have to prove? Angle ABC plus angle ADC, the opposite angles of the quadrilateral, are supplementary, that is equal to 180 degree. ABC plus ADC is equal to 180 degree. Angle BAD plus angle BCD, okay, is equal to 180 degree. Construction: join OA and OC. This point, this is the circle center, just you have to join OA and OC. Okay. Now see here children, angle AOC and here angle ADC, are they not forming, are they formed by the same arc? Okay, this is formed on a circumference, so this angle ADC will be half of angle AOC, right? And from this side you see this circumference, suppose this the bigger circumference, this one ADC, this one the whole bigger side, the the point ABC is, and this will be the circumscribed point circle, sorry, this will be the reflex angle AOC. So reflex angle AOC is equal to 2 times ABC. Okay, here ADC is equal to half of AOC and reflex angle ABC is equal to, sorry, ABC is equal to half of reflex angle AOC. Now let us continue. Proof, statement and reason. Arc ABC subtends angle AOC at the center and point ABC at the point D of the remaining circumference. We have seen that. Therefore, angle AOC is equal to 2 into angle ADC. Angle ADC is equal to half of AOC. Angle at the center is twice the angle at the remaining circumference. Okay. Now, similarly, angle ABC is equal to half reflex angle AOC. I have told you that. Therefore, angle ABC plus ADC, both the angles if you add, okay, is equal to half of reflex angle AOC plus AOC, that is half into 360 degree. Reflex angle AOC plus AOC is 360 degree, and when you add these it will give you 180 degree. Reflex angle AOC plus AOC is equal to 360 degree. Similarly, angle BAD plus BCD is equal to 180 degree. Here you have proved ABC plus ADC. Similarly, you can prove it for BAD and BCD, and therefore it is proved that the angles in the opposite of the cyclic quadrilateral are equal to, add up to 180 degree. So now remember children, there are some points. If the opposite angles of a quadrilateral, angle ABC and angle ADC here, are supplementary, means add up to 180 degree, ABC plus ADC is equal to 180 degree, or BAD plus BCD is equal to 180 degree, then what happens, that the quadrilateral is cyclic. Okay. Angle of major segment is acute. Major segment, which is the major segment here children? This is like this one is the major, this one is the ADC is the major segment. Okay. And ABC is the major segment and ADC. Okay. In the above figure, ABC is the, if the angle of the major segment is acute, okay, and angle of the minor segment is obtuse. Minor segment means, suppose, see this. In the above figure, ABC is the angle of the major segment. So it is acute. That is, angle ABC is less than 90 degree. In the same way, angle ADC is the angle of the minor segment. So it is obtuse. That is, angle ADC is greater than 90 degree theorem. Okay. So angle ADC is greater than 90 degree. Okay. It is obtuse. Now coming to theorem 5, children. Okay. The exterior angle of a cyclic quadrilateral is equal to the interior opposite angle. Given a cyclic quadrilateral ABCD whose side AB is produced to point E. To prove exterior angle CBE is equal to angle ADC. CBE is equal to angle ADC. The statement, the proof, the statement and the reason. Angle ABC plus angle CBE. What is it? It is equal to 180 degree because they are angles on a straight line. Also children, angle ADC plus angle ABC is equal to 180 degree. That is because the opposite, the angles are supplementary of a cyclic quadrilateral. Then see this, ABC plus ADC is equal to 180 degree. The reason is given. Then angle ABC plus CBE we have found out 180 degree, and it is equal to angle ABC plus ADC. ABC and ADBC again we can cancel out, and then we can find that angle CBE is equal to angle ADC. Hence it is proved that exterior angle CBE is equal to angle ADC, the opposite angle of the cyclic quadrant. Now similarly in the adjoining figure, okay, what you can see, angle PAB, this angle will be equal to what? DCB or BCD. It is written here. Suppose we take this angle CBQ or QBC will be equal to angle ADC, right? This is the opposite angle. Then if we take angle DCR or RCD, then it will be equal to angle DAB or BAD and so on. Okay. All the exterior angles will be equal to the opposite angle in the cyclic quadrilateral. In the given figure, angle AOC is equal to 110 degree. We'll take up the question, children. Calculate angle ADC, ABC and angle OAC. The solution, children, angle ADC is the point on the circumference, angle on this formed on the circumference by the same arc or the same segment. Okay, so it is half of angle AOC, which is given as 110. So it will be equal to 55 degree. Okay, half of 110. Now what we can see is that angle ABC, we have to find angle ABC. Okay, so angle ABC plus angle ADC is equal to 180 degree, and we know what is the value of ADC, 55 degree. So 55 degree minus, sorry, 180 degree minus 55 degree will be 125 degree. This is 125 degree. Now for finding OAC, what do we have to do? We have to join A and C together. OAC. Suppose OA is equal to OC. We don't have to suppose, this is radii. So OA is equal to OC. So the opposite angles are also equal. Angle OAC is equal to angle OCA is equal to OCA. And what about the three angles in a triangle? They are all equal to 180 degree. 110 degree plus angle OAC plus OCA is equal to 180 degree, or 110 degree plus 2 times angle OAC is equal to 180 degree, and 180 degree minus 110 is 70 degree. Half of 70 degree will give you 35 degree. Okay children, the solution is given in the given slide, and you can read from here how it has been done. Okay, the same thing I have explained you through the diagram. Okay, so you can see here angle OAC is equal to 35 degree. That is the answer. In the adjoining figure, PQ is equal to PR. PQ and PR are equal, and PRQ is 70 degree. Okay, PQ is equal to PR means that, and finding QAR, find QAR. This, you can see children that this QPR and QAR are in the same, are forming angles at the same circumference, means are form the same segment. Okay, so one side is 70 degrees, so other side will also be 70 degree. When two sides are equal, and this side also will be 70 degree. So 180 minus 70 plus 70 will be 140 degree. This P angle will be equal to 40 degree, and again QAR and QPR are the same angles. So are the angles subtended at the circumference by the same segment. Therefore, QAR will be also equal to 40 degree. So the solution is given: angle PQR, in triangle PQR, PQ is equal to PR. So we find out that angle QPR is equal to 40 degree. Okay, and then because they are in the same segment, therefore their the angle QAR is also equal to 40 degree. In the given figure, the given figure shows a circle through the points A, B, C and D. If angle BAC is equal to 67 degree, find angle DBC plus DCB. Okay. See children how it is given: A, B, C, D. Okay, this is the circle, and this C. Again you see that this is same segment, and this is also in the same segment. So this and this will be equal to 67 degree, right? BDC will be also equal to 67 degree, right? And what is the angle? Then this is what we have to find out, that angle DBC plus BCD we have to find out. DBC plus angle BCD. It is very easy children. See, once you have found out this, that is 67 degree, then what we will do, we will take this triangle BDC. Okay, when we take this triangle, what happens is that this is 67 degree, so angle DBC plus angle BCD will be equal to 180 degree minus 67 degree, because they are sum of angles in a triangle, is equal to 113 degree. Okay, that is the answer. The sum of the is equal to 113 degree. In the given figure, fourth question children, in the given figure, BC is parallel to DE and O is the center of the circle. If angle CDE is equal to x degree, find in terms of x degree the value of angle BAC. Okay children, see, BC is parallel to DE. Okay, so when BC is parallel to DE and it is given that angle CDE is equal to x degree, that is this one. So when we see that this thing DC is the transversal and BDE and BC are parallel, so what will happen is that EDC will be equal to BCD, right? Interior alternate angles, they will form a Z shape, right? Like this, like this. This is a Z shape, and then this, they are the alternate angles. Now, children, what we have to find is, the question says to find the value of BAC. Okay. If we join BO and OC, okay, then what happens if we can find the value of BOC in terms of x, okay, then we can find the value of BAC, because it will be half of BOC arc. It is subtended by the same arc at the center and circumference. Okay, now see this segment, children. CE segment is COE is equal to 2 times CDE. Is it correct? COE. COE is a segment which is, COE is the angle formed at the center, and CD is the angle formed at the circumference by the same segment, that is CE. Okay, by the same arc CE. So angle COE will be equal to 2x degree. Okay, this one will be equal to 2x. This one will be equal to 2x degree. Okay. Now coming to this children, this segment DB. Okay, this segment DB. What do you see, children? DB, this angle. Okay, sorry, this angle and this angle is equal to x, and what is the this angle subtending at OBOD? This angle will be is equal to twice the angle BCD. BOD will be equal to 2 times BCD. This will also be equal to 2x. Right, children? This will also be equal to 2x, because see, it is subtending at the center and at the circumference. Okay. So same thing I have done. Then what is left here, children? This is equal to 2x. This is equal to 2x, and these are in a straight line. So angle DOB plus angle EOC plus angle BOC, okay, is equal to 180 degree. We know this angle is 2x. This angle is 2x. So 180 degree. So 2x plus 2x plus angle BOC is equal to 180 degree. Okay. So what will be the angle BOC? It will be 180 minus 4x. Okay. And what will be angle BAC? It will be half of it. Okay. Let's see. We have joined OB and OC, and since angle at the center is twice at the angle at the remaining conference, the remaining circumference, so angle COE is equal to 2 into angle CDE. We have seen that is 2x degree, and angle BOD is equal to 2 into BCD is equal to 2x degree. Now DOE is a straight line diameter. Therefore, angle DOB plus BOC plus COE is equal to 180 degree. 2x degree plus angle BOC plus 2x degree is equal to 180 degree. Okay, because DOB and COE we have found out that they are 2x degree. Angle BOC is equal to 180 minus 4x. Angle BAC is equal to half of angle BOC is equal to half of 180 minus 4x is equal to 90 minus 2x. That is the answer. Okay. Now coming to the second method. Children, first method was easier, so I did by that method, but there are two more methods by which this question can be solved. So whichever method you find easy, you can choose that method. Okay. Now in this question, in this method, what we do, we join CE and BD. Okay. See here, we join CE and BD. So children, what happens is that, what is the value of BCE? Children, here this angle is in a semicircle. DE is the diameter and DCE is the angle formed in the by a diameter. So it is equal to 90 degree. Okay. Now see angle DC, triangle DCE. In triangle DCE, now what is the value of angle DEC? Angle DEC is equal to angle 180 minus 90 minus x degree, because it is a triangle. So 180 minus 90 is 90 minus x degree, that is 90 minus x degree is this angle. Okay. Now coming to this, see this quadrilateral, children, BECD. BCED. This is a cyclic quadrilateral. So this angle is equal to this angle and this angle is equal to this angle. Okay. So we have found this angle 90 minus x degree. So what is the value of angle CBD? Can you find out? 90 minus x is here and 180 minus, because the opposite angles are supplementary, therefore 180 minus 90 minus x will become 90 plus x. So this angle will be equal to what? This angle will be equal to 90 plus x degree. Okay. So it will be equal to 90 plus x. Now this angle and this equal to 90 plus x. So what happens that when we see this quadrilateral, this triangle BDC, okay, one angle is equal to x degree, second angle is equal to 90 plus x degree. So what is the angle BDC is equal to? Third angle will be 180 minus 90 minus x, that is 90 minus x, right? This angle will also be equal to 90 minus x. So 90 minus x, this angle is 90 minus x. Then what about this angle, children? It is by the same segment BC. This BC segment subtends an angle at the circumference D and at the circumference at point A. So BTC is equal to BAC is equal to 90 minus 2x degree. Okay. So let's see how it has been solved. Understood, children? First we have found this is 90 degree. Then we have found that this value is equal to 90 minus x degree. Then after that, by seeing this as a cyclic quadrilateral, we have found the value of CBD, then the value of BDC by finding the sum of angles in a triangle, and this angle is equal to this because they are the angle subtended by the same arc at the circumference. Okay. Angle CDE plus angle DEC is equal to 90 degree, x degree plus angle DEC is equal to 90 degree. Therefore, angle DEC is equal to 90 minus x degree, right? Because the remaining angle of the triangle will be equal to 90 degree, because one angle is 90 degree, so the remaining angle will be equal to 90 degree. Now, since BCED is a cyclic quadrilateral, therefore angle CBD plus angle CED is equal to 180 degree, because opposite angles are supplementary. Therefore, angle CBD plus CED, what is the value of CED? Angle 90 minus x is equal to 180 degree. Therefore, angle CBD will be equal. Therefore, angle CBD is equal to 180 minus 90 minus x degree is equal to 90 plus x degree. Angle BCD is equal to CDE is equal to x degree. Also in triangle CBD, angle CBD plus BCD plus BDC is equal to 180 degree. 90 plus x degree plus angle BDC is equal to 180 degree. We have already found these angles, angle CBD and BCD. So we equate them because sum of angles of a triangle is equal to 180 degree. Now if we find out the value of BDC, it is equal to 90 minus 2x degree. And now angle BAC is equal to angle BAD is equal to angle BCD is equal to x degree because angle of the same segment. Angle DAC is equal to angle DEC is equal to 90 minus x degree because the same reason that angle of the same segment. Okay, it implies that angle BAD plus angle BAC is equal to 90 minus x degree. What is the value of BAD, children? Angle BAD is equal to x degree plus BAC is equal to 90 minus x degree. Therefore, angle BAC is equal to 90 minus 2x degree, and that is the answer. In the adjoining figure, AC is a diameter of the circle, AB is equal to AC, and angle AED is equal to 118 degree. Calculate angle DEC and secondly angle DAB. Okay. So we will join EC and AD. Okay. Now, what is the value of angle AEC, children? Can you see? This angle is also framed in a semicircle, as well as angle ADC. This angle is also in a formed in a semicircle. So this angle will be equal to angle AEC will be equal to 90 degree. So what will be the angle to DEC? That will be 118 minus 90 degree. That will give you 28 degree, right? So angle DEC will be 28 degree. Now we have to find out DAB. So here it is 28 degree again because this DEC and DAC, they are angles in the same segment. So this is also 28 degree, and 28 plus 45. What is 28 plus 45? That is 73 degree, right? So angle DAB will be equal to 73 degree. See here, we have done the solution. First we join EC and angle AEC is equal to 90 degree angle in a semicircle as AC is the diameter. Okay. Then secondly, DEC is equal to 118 minus 90 degree is equal to 228 degree. That is the answer. Now when we join AD, angle DAC is equal to DEC. We found that because they are angle in the same segment. DC, that is 28 degree. Angle ABC is 90 degree. So BAC is equal to BCA is equal to 45 degree. It is already given because both the sides of the triangle are equal. Okay, so angle DAB is equal to angle DAC plus BAC, which is 28 degree plus 45 degree, which we have found out from above. This DAC is 28 degree, and then for the answer comes as 28 degree plus 45 degree is equal to 73 degree. Okay, children. In the adjoining figure, O is the center of the circle. Chords AC and BD are perpendicular to each other. Angle OAB is equal to A and angle DBC is equal to B. Show that A is equal to B. See, A in this angle ADB, the chords AC and BD cut each other at 90 degree. Here this is 90 degree, so this is also 90 degree because it is opposite. Okay, now if they are perpendicular to each other, so this side is also perpendicular. So what happens is that now what we see here, see, we have angle the OAB is equal to a degree. OAB is equal to a degree. Okay, when OAB is equal to a degree, then OBA is also equal to a degree, because OA and OB are the radius, and therefore opposite sides are equal, therefore the opposite angles are equal. Okay, so if OA is equal to OB, then this A, then what happens is that this we have got that A value of OBA. Okay, now we have to find out the value of, now we have to we can see that CBD. Okay, and angle ACB. What is the value of angle ACB, children? We have to find out. First, let us see this triangle. In this triangle, the value of angle AOB is equal to 180 minus 2A. Okay, because the sum of the angles in a triangle is equal to 180 degrees, therefore 180 degree minus 2A. So this and this angle D and C will be equal to half of 180 degree minus 2A, that is 90 minus A both. Okay, this angle is already 90 degree, this angle is 90 minus A degree, and when we add all the three, what we get? 90 degree, 90 minus A degree, and B degree, okay, is equal to 180 degree, 90 degree, 90 minus A degree plus 90 plus B degree is equal to 180 degree. Here 180 degree on the left hand side also, and right hand side also, so they get cancelled. So minus A plus B will be equal to 0, and A is equal to B. That is how we prove it. Okay, like in triangle AOB, see, we have taken the radii of the same circle, therefore the angle is equal to A degree. Then angle AOB is equal to 180 minus 2A. We have seen that. Angle ACB is equal to angle on the remaining circumference is half the angle of the center. So 90 minus 80. Given chord AC and BT are perpendicular to each other, therefore angle ACB plus DBC is equal to 180 degree, and 90 minus A plus B is equal to 90 degree. Okay, 90 minus angle ACB is equal to DBC is equal to 90 degree, and 90 minus A degree, this one, plus B degree is equal to 90 degree, because because the remaining angle which remains is 90 minus A, because 90 is already cancelled and the remaining angle is 90 degree. With this should add up to 90 degree. Okay, because one angle is 90 degree already, so other two angles should add up to 90 degree in a triangle. So minus A plus B is equal to 0, therefore A is equal to B, and that is the answer. Okay, in the adjoining figure, ABCD is a cyclic quadrilateral. Angle CBQ is equal to 48 degree and A is equal to 2B. Calculate the numerical value of B. Okay, calculate the numerical value of B. Let's see what is there. Now come to the figure, children. We can see that A, B, C, D. This is the cyclic quadrilateral which has been given. What is the value of, and this CBQ? Okay, this value is equal to 48 degree. This line has been extended till here to till Q, and this also has been extended till Q. Okay, and they have joined and they form angle Q. The value of BQC is B degree. Okay, now see this, children. If this is 48 degree and this is B degree, then what is the value of angle C DCB in DCP? It is 48 plus B. How? Because exterior angle of a triangle is equal to sum of opposite angles in a triangle. Okay, of the opposite angles in a triangle, like this exterior angle will be equal to sum of opposite angles. Okay, now see, children, it is given in triangle BCQ. angle DCB is equal to 48 plus B, which we have proved. Okay, sum of interior opposite angles. Now see A, P and B. This angle is equal to 48 degrees. So this angle is also 48 degree because they are vertically opposite angles. Okay. Now, and this angle, what is the value of this angle? This angle is equal to A degree. Okay. It has been given. And what is the value of B, A? A is equal to 2B. Okay. And we have to find out the value of numerical value of B. Okay. Now, if this angle is A and this angle is 48 degree, again we use the same logic that exterior angle of a triangle is equal to sum of interior opposite angles, that is 48 plus A. Therefore, this angle DAB will be equal to 48 plus A. Now, what is the value of opposite angles, sum of opposite angles in a triangle, children? Sum of opposite angles in a triangle is equal to 180 degree. Okay, of a cyclic quadrilateral, not a of a cyclic quadrilateral is, so 48 plus A plus 48 plus B will be equal to 180 degree, and hence we can find out the value of B. Okay, now let's I hope you have understood. We will add this up to 180 degree and then we put the value of A as 2B and we can find out the value of B, numerical value. So see here, angle DAB is equal to angle ABP plus A, just like 48 the previous uh, exterior angle. So exterior angle equal to sum of interior opposite angles, therefore 48 degree plus A. Now in cyclic quadrilateral ABCD, DCB is equal to DCB plus DAB is equal to 180 degree. Opposite angles of a cyclic quadrilateral are supplementary. We know that. So 48 degree plus B degree plus 48 degree plus A degree is equal to 180 degree. Okay. DCB plus DAB. Okay. So A, what we will have, A plus B is equal to, what is 48 plus 48? 48 plus 48 is 96. 96, 180 degree minus 96 degree will be 84 degree. Now A plus B is equal to 84 degree. That means 2B plus B is equal to 84 degree. Given A is equal to 2B, therefore A is equal to 2B, therefore 3B is equal to 84 degree. Therefore, angle B is equal to 84 by 3 and therefore it is equal to 28 degree, which is the answer. In question number 8, in the given figure, angle BAD is equal to 80 degree, angle ABD is equal to 55 degree and angle BOC is equal to 45 degree. Find angle BCD and angle ADB. So, show that AC is the diameter. So now BCD, what is the value of angle BCD? That is equal to 100 degree. So that angle is equal to, AC is the diameter, so AC, so this value, this angle is equal to 80 degrees, so this value will be equal to 100 degree because they will add up to 180 degree because they are angles of the opposite angles of the cyclic quadrilateral. Now this angle has been given as 55 degree. So when we take this triangle ABD, then what we get, this angle is 55 degree, this is 80 degree. So what will be the value of this angle? This angle will be equal to 45 degree. Okay, but how? By subtracting what 80 plus 55, that is 135 from 180 degree, which is will give you 45 degree. This angle is already given that it is 45 degree, and when we add these two angles, what we get? 90 degree, right? CDA becomes 90 degree. So when an angle is formed in a semicircle, then only it is 90 degree, okay, on the circumference. So we can prove that AC is the diameter. Okay, so from this we can prove that AC is the diameter, or angle formed in a semicircle is 90 degree because CDA is equal to 90 degree. I hope you have understood. If you have any problem, just read it once again, listen to it once again. Only that AC is the diameter. We will see that this angle is 90 degree, so we can say that AC is the diameter. Okay. Now this has only been solved here. See, this angle has been given, this was given, and this was given. Okay, and this angle we can find out it was equal to 100 degree. This angle we found out as 45 degree, and this angle was already given. So when we add these two angles, we get 90 degree. So when this is equal to 90 degree, then this is the diameter. Okay, see, you can solve it. Now coming to the question number 9, children. In a circle with center O, a diameter AB and a chord AD are drawn. Diameter AB and a chord AD are drawn. Another circle is drawn with AO as diameter to cut AD at C. Prove that BD is equal to 2 into OC. So here, children, what happens is that according to the given statement, we will find out the solution. This is the first circle A, B, this circle, big circle, and the second circle touches here, and this is the center of the O is the center of the bigger circle. Okay, and OA, what do you think is the diameter, right, of the second circle, and OA is the radius. Okay, now if this and this are proportionate and this angle is equal to 90 degrees, so this is the diameter. Okay, now if we take this smaller circle, then here also we see that this is the diameter of the circle and this is the center, and here also, because angle in a semicircle will be equal to 90 degree. So this ACO and ADB will be equal to 90 degree. Okay, and this side and this side are equal. So what we can say is that, and this angle is common for both the triangles ACO and ADB. Okay, so what we can say that angle ACO and angle ABD are congruent to each other. So therefore AC upon AD, AC is half of AD, and therefore CO is half of DB. Okay, let us see this how we have solved. According to the adjoining statement, the figure will be shown alongside angle ACO is equal to angle ADB is equal to 90 degree because they are angles of the two semicircles. Now OA is the radius and AB is the diameter. Therefore, OA is equal to half of AB. OA upon OB is equal to 1 by 2. OC is also perpendicular to the chord AD. Okay, so AC is equal to half of AD. AC upon AD is equal to 1 upon 2, right? Because the OC is perpendicular to the chord AD. Now coming to then in triangle AOC and angle AOBD, ABD, OA upon OB is equal to AC upon AD and angle A is common. Okay, two sides are proportionate and the angle AOC is, therefore we can say that triangle AOC is congruent to triangle ABD. Okay, by SAS, side angle side theorem. Okay, therefore OC upon BD is equal to OA upon AOB is equal to 1 by 2. Therefore BD is equal to 2 times OC. Okay, alternative method is also there, children. First, we know that because OA is equal to half of OB, because therefore implies that O is the midpoint of AB. Therefore AC is equal to half of AD. Okay, AC is equal to half of AD. Therefore, OC bisects the chord. In triangle ABD, OC is equal to half of BD. Line joining the midpoints of two sides of a triangle is half the third side. Okay, because they are joining the midpoints of two sides of a triangle is equal to the half of the third side. Therefore, OC is equal to half of BD and BD is equal to 2OC, which can be proved. Okay. AC is equal to half of AD. Okay. So if AC is equal to half of AD, therefore, because OC bisects the chord. Understood? So OC is equal to, because line joining the midpoint of this is the uh, explanation for this, and therefore this will be proved in just 3 steps. Okay, now coming to the question number 10, children. In the figure given alongside O is the center of the circle and angle AOC is equal to 160 degree. Prove that 3 angle Y minus 2 angle X is equal to 140 degree. See here, children, this is 160 degree angle AOC and this is the reflex angle of it, which will be equal to how much? 360 minus 160, that is 360. This total must be equal to 360 degree. So this is equal to 360 minus 160 degree, that is 200 degree. Okay, this is equal to 200 degree. And what is 200 degree? 200 degree is equal to 2y. Okay, because angle at the circumference is twice, angle at the center is twice the angle of the circumference. So 200 is equal to 2y, therefore y is equal to 100 degree, right? Now coming to x, if we take x, then this value, this x, this is x, and x is equal to 80 degree, and this value is equal to twice times 2 times, because it will be AOC will be equal to 2 times this angle from that the circumference. Therefore 160 degree will be equal to 2 times x, and x value will be equal to 80 degree, right? One, then 3 into y, what we found out the value of y as 100. So 300 minus 2 into 80. What is 280? 2 into 80, it is 160. So 300 minus 160, what will you get the answer as? 140. Okay, so we can get easily once you find out, but here you have to just be cautious about which is the side which we have to take for the angle at the center and the circumference. Okay, since opposite angles of a cyclic quadrilateral are supplementary, therefore x plus y is equal to 180 degree. Y is equal to 180 minus x is equal to 180 minus 80 degree. This you can use this as theory also. Okay, so to prove that this is equal to 100, y is equal to 100 degree. Okay, now 3y minus 2x is equal to 300 minus 160, that is 140, which is proved. Now coming to the question number 11, children. Two unequal circles with centers A and B intersect each other at point C and D. Okay, the center B of the smaller circle, okay, lies on the circumference of the bigger circle with center A. If CMD is equal to x degree, find in terms of x the measure of angle DAC. Okay, so let us see the figure, how it is given. See the figure, children. There are two circles. One is this one and one is the second one. They both are intersecting at points C and D. Okay, and this is point A, point B, which is the center. of the second smaller circle. And what is the point A? It is the center of the bigger circle. Okay. Now children, if you see here, what is the value of what we have to find out, that here for the first you see here CMD, it is equal to x degree, and CB, yes, CBD is equal to 2x degree, because the angle formed at the center is equal to twice the angle formed at the circumference. Okay. Now what is this angle, children? This angle is 360 degree minus 2x. Okay. And it is half of this angle, sorry, twice of this angle. Okay. Now since the angle at the center is twice the angle at the remaining circumference, therefore in circle with center B, okay, angle CBD is equal to 2 angle CMD is equal to 2x degree. We can see that angle at the, okay, center. Now in the bigger circle, angle bigger circle D is DBC is a DBCN is a cyclic quadrilateral, and we know that angles of a cyclic quadrilateral are supplementary. Therefore, angle DNC plus CBD is equal to 180 degree, and angle DNC plus 2x degree will be equal to 180 degree, and angle DNC is equal to 180 minus 2x degree. Okay, that is the angle formed at the circumference. Again, angle at the center is equal to twice at the remaining circumference. Therefore, angle I have shown you that in the bigger circle, this angle reflex angle, that is angle BAC is equal to 2 into 180 minus 2x degree, that is 360 minus 4x degree. Okay. Now coming to the 12th question, children. The given figure shows a triangle ABC with angle BAC is equal to 56 degree and angle ABC is equal to 64 degree. Bisectors of angle ABC meet the circumcircle at P, Q and R respectively. Find the measure of angle QPR. Okay. Let's see how the in the given triangle ABC, ABC plus ACB plus BAC is equal to 180 degree. Okay. Now coming to the part that, see, these angles have been bisected by these lines. AP bisects A, BQ bisects B, and CR bisects angle C. So these this angle is equal to this, so they are equal. Okay, the bisect means they are bisect. If this angle is equal to how much, the value is given as ABC value is given as 64 degree, so this angle will be 32 degree and this angle will be 32 degree. If it is, this is angle A is equal to 56 degree, then this is 28 and this is 28. Okay. So, and what is the value of this angle? 56 plus 64 means it equal to 120. 180 minus 120 is equal to 60 degree. Angle ACB is equal to 60 degree. Okay. Angle QPA. Angle QPA. What is the value of angle QPA? It is equal to angle QBA is equal to half of angle ABC. Okay, how half of angle ABC? Because angle QPA here, QPA, because they are the angles formed in the same segment. Okay, see this segment and see this segment, QPA, and so we have to find out QPR. So we will be trying to find out this point and this one. Okay, so we have found out the value of this one, that is 32 degree, right? This is 32 degree angle QPA. Now consider this segment, children. This angle QRPA, okay, will be equal to what? Angle, this angle RCA, right? Because angle, they are both in the same segment. This angle will be equal to this angle C. Half of angle C. What is angle C? Half of angle C. That is, we found out 30 degree. 60 degree is angle C, therefore half is 30 degree. So this was 32 degree and this comes as 30 degree. So the total value of QPR will be equal to 62 degree. Okay. Now see the answer. How solution, children? This value adding up will give you 180 degree. 64 degree plus ACB plus 56 degree is equal to 180 degree. Angle ACB is equal to 60 degree. QPA, I have just explained you all this. You can just read through it and you will get the answer as 62 degree. Okay. Now coming to children, question number 13. In the given figure, I is the in center of the triangle. What do you mean by the in center? That inside the circle, sorry, in the triangle, a circle is drawn, and that is, and the center of that, where the all the a bisectors meet, that is called the in center. AI is meets the circumcircle of the triangle ABC at point D. If angle BAC is equal to 50 degree and angle ABC is equal to 70 degree, find BCD, ICD and BIC. Okay. Here I is the in center of the triangle. See, the bisectors of the angle of the triangle meet at one point, that is I. Okay, and I has been extended to point D. Okay, here I is the in center of the triangle ABC, means I is the center of the circle that touches all the sides of the triangle ABC, and it is the point of intersection of the bisectors of angle of triangle ABC. It is also the center of the circle and it is the point of intersection of the bisectors of the angle. That is, IA bisects angle BAC, IB bisects CBA, okay, and IC bisects ACB. Okay. See, children, in this diagram we will join IB, IC and ID. Okay, IC and CD. Now children, can you see this? Since the I is the bisector of the in center, okay, is the in center, sorry, is the in center, so IA bisects this thing BAC, it is equal to 25 degree. If you see this segment BD, this segment, and you see here, what is angle BAD is equal to 25 degree, right? Because it is bisected. And if you see same BD segment, what value is it giving here? Angle BCD, what is equal to this? This will be equal to 25 degree again, because they are angles at the circumference formed by the same segment BD. Okay, this BD segment forms two angles at the same. Then this angle BAD is equal to 50 degree and angle BAC is equal to 25 degree, and angle BCD is also 25 degree. Now coming to this point, children, this IC bisects this angle, so this will be 30 degree and this will be 30 degree, right? So now IC bisects this angle, therefore this angle is 30 degree. If angle I, therefore total angle ICD is equal to ICB plus BCD. ICB also we have found out, and BCD also we have found out. The total of these two angles is 30 plus 25 is equal to 55 degree. That is the answer. Now coming to the third part, children, IBC, angle IBC. Angle is equal to half I of angle ABC because it bisects. So uh, therefore half of 70 degree is equal to 35 degree. Now angle BIC is equal to 180 degree minus angle BIC minus angle ICB, because they are angles in a triangle, right? So 180 degree minus 35 degree minus 30 degree is equal to 180 minus 65 degree is equal to 115 degree. That's all, children, from my side. This chapter has been started, and I had taken much time, means I have come back after a long time because I was not well, keeping well. So children, might be that this slide was prepared long time back, but it has come to you a little later. Okay, so this was all in the circles first part. Then we will come to the circles exercise also. I have prepared quadratic equation 5e also, and then I am preparing some other chapters also for you. So please read the whole slide, go through whole slide, and please go through all the sections, and especially in this you have to remember that angle at the circumference is equal to twice at half at the center, this one in this exercise. Okay, so you have to find out that. So thank you, children, thank you very much. Now coming to the, I hope you must have understood the chapter. Don't take too much burden on your head, children. Everything we just study and leave the result on God. Okay, means your duty is to study and not to bother about the results. Okay, children. Thank you very much, children. Please like and subscribe my channel, and please press the bell icon so that whenever I load my videos, you can see them at the very first instance. Okay, so all the best for your exams. God bless you all. Be happy always. Thank you, children. Thanks a lot.